Hello everyone. So this is our project PotatoGuard. पहले तो introduction से start करते हैं. So PotatoGuard aims to revolutionize potato farming by leveraging deep learning techniques to detect diseases in potato plants. Through a user-friendly web app, farmers can simply capture images of their crops, and our advanced CNN model built with TensorFlow and data augmentation techniques will accurately identify any diseases present. Utilizing TF serving and fast API for backend server operations and model deployment, PotatoGuard ensures seamless integration and scalability. PotatoGuard represents a cutting-edge solution in agriculture, merging AI technology with practical farming needs to support sustainable crop management and economic viability for the farmers worldwide. So this is the dataset we have used for our project, the plant village dataset on Kaggle. It has images for a number of plants, so we have selectively taken the images or the folders directories related to potato plant. And once we have downloaded this data set, we have used the same to train our model. So this is the overall code for our model training. So we have first imported all the necessary dependencies like TensorFlow, etc., and then defined or set all the constraints like batch size and the number of epochs to run while the model is getting trained. Then we have imported the data set and visualized the same to check if it is getting loaded properly or not. And then we have finally split the data set into three parts, 80% of which is into the training set, 10% into testing, and 10% into validation, as can be seen here. So yeah, training size is 80% and so on. Once we have split the data set, then we start building the model. So for proper building, we'll first normalize the data, that is so that all the images have values in the range of 0 and 1 instead of 0 to 20 to 55. Then we have augmented the data for boosting its accuracy, for boosting the accuracy of our model. And then we have finally defined different layers like max pooling and convo 2D and also dense layers. So basically here we have built a CNN model, we have defined its architecture, and then finally the model gets trained in this model.fit segment of the code. Once the model has been trained completely and all the 50 epochs have run, we finally get a model with accuracy of about 97%, as can be seen here. Now, and these are the accuracy and loss functions we get for our model. So these graphs help us visualize the accuracy and loss of our model. And once the model is trained, we can test it whether it is predicting based on the image correctly or not. Now, once this is done, once the model is trained, we have worked on the backend. So for this, we have used TF serving and fast API and Postman to check for the methods like the post method and all. So yeah, this is our backend where we have defined what the predict method will do. So here, as we can see, the predict method will take in a file and run the model on this file and predict the output. The output will have the result will have two sentences or lines in its output. The first one will predict the class of the potato leaf, the image which we have uploaded. So it can either be early blight, late blight, or healthy. And confidence will tell about the confidence score of the model or of the image. So as we can see on the on this Postman, so we have tested our method here. So we uploaded a potato image leaf here, the image of a potato leaf on this model, and the model predicted it to be early bright with a confidence of 0.66. So yeah, and it was actually an early bright leaf as well. So the model correctly predicted it in this case. Then finally, once the backend is done, we have also tried building a simple front end for now. So this is the code for the same, and this is a simple front end for our app. So from here, the user can choose an image and upload the image. We are yet to integrate it with the backend, but once that is done, so the image which the user uploads here will be taken in by the backend, and the model will run on the same to predict the category or class of the leaf. So this is our overall model. Yeah, so thank you.